In this lesson, we're going to revisit the concept of probability. You may recall we did an investigation into probability. We flipped the coin a bunch of times. We noticed that as we continue to flip the coin again and again and again, as we kept track of the number of heads and the numbers of tails, we found that the numbers seemed to approach 50% heads and 50% tails. That's what we find out. As we do something that has a set of outcomes that are equally likely, as we continue to do that task that has those outcomes, if we do it many, many times, each of those outcomes will tend to happen the number of times we would expect based on their probability. That's what we're going to be looking in today. How do we figure out what a probability of an event happening is? How do we calculate that? There are a few terms that you're going to need to know that you're going to put in your notes. First of all, you're going to want to put the term sample space into your notes. Okay, so make sure you have your notebooks out and you're putting this in there. A sample space is the set of all possible outcomes of an event. For flipping a coin, the sample space would look like this. Now, we have a set, so we're going to use set notation, right? I'm just going to write sample space equals. So our set notation, we use squiggly brackets, and then we list the possible outcomes, heads, comma, tails. There we go. Rolling a dice, the sample space looks like this. Squiggly brackets, 1, 2, 3, 4, 5, 6. Because we can have all of those possible outcomes. So a sample space is just a set of all possible outcomes. We can count how many outcomes there are in the sample space, and that tells us how many different possible things can happen as the result of an event. And the events that we're really interested in are the ones where all of these outcomes are equally as likely as one another. So flipping a coin, there's no preference whether your coin, as long as it's a fair coin, there's no preference whether you're going to get heads or tails. It's 50%. There's a 50% chance you get either one. Same with rolling a dice. There's no preference on a fair dice whether you're going to get 1, 2, 3, 4, 5, or 6. So each of those is equally likely to happen. A simple event is when we identify one particular outcome. So I'm just going to note that this is an event that we identify. I'm adding that language to what's in Saxon to make it a little clearer. You're just identifying a specific outcome that we're looking for that has only one outcome. And it could be a set of outcomes in the sense that we could say, okay, you're rolling a dice. So that's something that's happening. Rolling a dice one time, that's your event. And we're going to look at the outcome of that one event. Is it going to be you roll a 4, 5, or 6, you roll a 1, 2, or 3? So you could say, what is the probability you roll above a 4 on a dice? And the simple event is rolling the dice. So that particular roll of the dice that we identified has one outcome. Then we roll it again. That's another event that's going to have another outcome. Okay? So that's what a simple event is. It's an event that has one outcome, and we're going to be analyzing those outcomes to identify what the probabilities of the different possible outcomes will be. And then lastly, the theoretical probability. That's what this lesson is all about. Theoretical probability is the ratio of favorable outcomes. And again, those are outcomes that we identify as the thing that we're looking for. Let's see, let me make sure I spelled probability right. I think I missed a few letters at the end there. The ratio of favorable outcomes to all possible outcomes. How do we find all possible outcomes? Well, we look at our sample space where we listed all possible outcomes. Okay, so if you look at that exploration, you'll note that we did an exploration similar to this. So we're not going to do this exploration, but just so you know, if you have 4 different colored marbles and you draw them out of a sack, and each one is as likely as the others to be drawn out, so they're the same size, they feel the same way, then the theoretical probability of drawing one of them out of 4 of them, okay, favorable outcomes is one particular one, maybe the yellow marble, to out of all of them, because there's 4 of them, it's going to be 1 to 4 or 25%. And as you continue to draw marbles out of the bag, you'll find out that you'll draw each one about 25% of the time, especially as you approach a lot of different events, a lot of different trials. You'll find that the number of times you get each one approaches a quarter of the time, okay? We already did that with flipping coins, so we're not going to repeat that here, but we are going to do example number 1. I'm talking about identifying sample spaces. So that's where we're going to go next. Example 1. A number cube labeled 1 to 6 is rolled. List the outcomes for each event. A number less than or equal to 3. So A, it's going to be in set notation, okay? Well, what are the choices on a dice less than or equal to 3? It's 3, 2, 1. Doesn't matter, by the way, in your set what order you put things in. So I could have put 1, 2, 3, and it would have also been correct. An odd number, well, the possible outcomes that are odd would be 1, 3, and 5 on a number cube, and then 2, 4, and 6 are even. A number greater than 4, now listen to the language, greater than 4. So 4 doesn't count because that has to be bigger than 4. That would just be 5 and 6, okay? You have to get used to listening to language very carefully in these assignments because they could give you one like that where they say greater than 4 just to check and see if you'll do greater than or equal to, and you'll include 4, but you're not supposed to. All right, so those are some examples of sample spaces. Now let's take a look at how we can calculate probability from doing the same thing. Example 2 says there are 4 green, 3 blue, and 3 red marbles in a bag. And we'll just assume each one is equally likely to be chosen out of the bag if you're not looking at them. What is the probability of randomly choosing a red marble? Okay, so that's part A. Well, there are 3 red marbles in the bag. And how many marbles are there? There's 4 green, 3 blue, and 3 red. So there's 10 marbles. So the probability of choosing a red marble is going to equal the probability of choosing, let's see, the number of red marbles, which are equally likely to be chosen, 3 red marbles, divided by the total number of possible marbles, including those 3. So there's 10 total marbles. And then 3 divided by 10 equals 0.3. We can express it as a decimal. We're also supposed to express it as a percent. So 0.3 expressed as a percent is 30%. There's a 30% chance I'm going to choose a red marble if I just draw one randomly out of the bag. Now here's something you need to know. The probability, and make sure you get this in your notes too. All of these examples should be in your notes. The probability of an event plus the probability of that event not happening. So I'm just going to write not event equals 1 or 100%. So the event, if you have a simple event, that simple event has to happen. If I flip a coin, I'm going to flip the coin, something's going to happen as a result of it. I'm either going to flip a heads or a tails, right? The probability of me flipping a heads is equal to the probability of me flipping a tails with that coin. And if I add up the probability of a heads and the probability of a tails, I should equal 1 or 100%, because the event is going to happen regardless of whether it's heads or tails. So there's 100% chance the event happens. There's only a 50% chance it's heads, 50% chance it's tails. When I roll a dice, there's 1/6 of probability of me rolling a 1. And the probability of me not rolling a 1, well, there's 5 other outcomes. So it would be 5/6 the probability of not rolling a 1. So this is an important equation for you to keep in mind. I'm just going to give you another version of this. The probability of an event not happening is equal to 1 minus the probability of the event happening. Okay, so I just rearranged that equation up above. Now let's take a look at letter B. This is what is the probability of randomly not choosing a green marble? Well, we know that the probability of choosing a green marble plus the probability of choosing an other marble that's not green equals 1. Or 1 minus the probability of choosing a green marble is going to give me the probability of not choosing a green marble. Probability not green, okay? Let me just get rid of my extra. I need to be consistent with my wording here. There we go. Okay, so what is the probability of choosing a green marble? I'm going to do 1 minus the probability of a green marble. Well, there's 4 green marbles, so it's 4 over 10 for choosing green. that's going to be equal to the probability of it not being green, and that's equal to 6 over 10 or 3 over 5. So that would be 3/5 is the same as 0.6 or 60%. There's a 60% chance I'm not going to choose a green marble. That makes sense because 4 of the marbles are green and 6 of them are not. All right, let's move on to the next one, calculating chance. Chance just means, the way that Saxon math uses chance, all they're talking about is which has a greater probability. And the thing that has a greater probability has more chance of happening. Okay, so let's take a look at example 3. It says, in a bucket there are 10 balls numbered as follows: 1, 1, 2, 3, 4, 4, 4, 5, 6, and 6. There's an extra 6. A single ball is randomly chosen from the bucket. What is the probability of drawing a ball with a number greater than 4? Is there a greater chance of drawing a number greater than 4 or a 1? Okay, so greater than 4 means it has to be 5, 6, or 6. How many possible outcomes are greater than 4? Well, there's 3 outcomes that are greater than 4. Can't include 4. And there's 10 total options. There's 10 total possible outcomes. So 3 over 10 equals 0.3 or 30%. There's a 30% chance of drawing a number that's greater than 4. That means that there's a 70% chance of drawing a number that's 4 or less. Okay? All right, so let's consider this. The probability of greater than 4 is 3 over 10. The probability of drawing a ball, let's see, it's just greater than 4 or a 1. The probability of drawing a 1 is, well, there's 2 1s out of 10. So I'm just going to make sure so this is going to be probability of drawing a 4 equals that. And then the probability of drawing a 1 equals 2 out of 10, which equals 0.2 or 20%. So there's a greater chance, that's how I would answer this one. There is a greater chance of drawing a number greater than 4 because it has a higher probability. All right, and then just one more example. It's important to work examples of this because this is a little bit out there. Let's take a look at the state fair example here. I'm just going to put this over on the side of our page. Let me just add a text box here. There we go. So in the state fair carnival game, you drop a ball on the top of the device. As the ball falls, it goes either left or right. The total paths the ball can follow is 16. But if you look at that device and you look at the possible paths, there's only 2 possible paths that lead to the $2 slots, right? One to the left and one to the right. It can't fall anywhere in the middle and then make it over to the $2. All the paths go pretty much straight down and branch off to the left or to the right. Okay, so they don't tell you that. This one's a little hard because they don't tell you that. You have to be able to look at the picture and realize, hey, there's only two possible paths that lead to $2. In total, the ball can follow 16 paths. The ball eventually lands in one of the bins at the bottom and you win that amount of money. One path is $0. One path to $0 is shown. Okay, so that's one possible out of those 16 paths. What's the probability of winning $2? Well, we know there's 16 paths. So let's just, example 4. And then the probability of $2, this is how I'm going to write this out, okay, equals 2 possible paths, or two possible paths of $2 divided by a total of 16 different paths that the ball can take, which equals 1 over 8. And I know that 1 over 8 is the same thing as 0.125 or 12.5%. And that's the probability of winning $2 is 1/8 or 12.5%. All right, now you know about calculating probabilities. This is kind of hard because you have to be able to think through what I showed you. You have to be able to think through what the total successful outcomes are and the total number of outcomes, and then divide those to get that theoretical probability. But now you are ready to work the practice problems 1 through 30. Pay special attention to the ones that deal with probability for next time.